Hello and welcome everyone to our weekly appointment with OpenShift Coffee Break. And as usual, we have our Jafar and Natale. Hi, Natale. Hi,
Hey
Jafar.
there, how are
And
you?
our guest
Good morning.
today,
Good morning,
Daniel
everyone.
Brintzinger. Is
Yes.
everybody okay today? Happy with your coffee?
Oh, yeah. Good morning, everyone. I hope you had your coffee shot to awaken your sense. Today, we are gonna try to awaken your sense with a nice talk about Quarkus on OpenShift. And I know Jafar and Daniel has a surprise for us. In the demo, there will be a new feature, new stuff, very cool stuff. I can say the word, Daniel. I can say MicroShift.
Yes, you can say it. You've already done it. So no pressure, showing completely new emerging
No
technology.
pressure at all.
So guys, stay until the end when Daniel is going to show us a little bit of MicroShift. And
By the way, Daniel, nice T-shirt. I like your T-shirt.
Thank you. Dev Nation, power of dev to the ops. So I think that's what all OpenShift is about anyway, bringing devs and ops together. So I think we'll talk about that today as well.
And we've had other occasions where we talked about Quarkus, but we thought it would be a great idea to get Daniel to take a step back and give us all the rationale behind Quarkus and talk a little bit more in depth about the technology. So, Daniel, what was your previous experience? Were you a Java developer? Did you work with Java? That's how you got to Quarkus?
Absolutely. I mean, Java has been with me from university through working at different companies. It was always like a constant technology which I worked with. Interestingly enough, at university, they would always switch in semesters teaching Java and then Scheme. And, you don't really hear a lot about Scheme projects nowadays anymore. So I was really lucky to have Java. And, I really love the language, love the technology. But at the end of the day, when you look at a certain language, a programming language, it's not just about the constructs. There may be some languages or runtimes out there that may be a little bit more elegant or have some kind of advanced features. But it's about the community, it's about the tooling, it's about the people who know it, it's about support, documentation, tooling, all these kinds of things. That's really what makes the power of Java in my perspective. And nowadays with tools like Quarkus, I mean, we can really take it to the next level now.
This is the first time in 20 years that I hear somebody speaking about Scheme. We used to use it in HP Labs. It was a particular dialect called P scheme. It was a distributed scheme. But ever since, never heard about it. Good that there's somebody else on the planet that had that experience.
Yeah, I actually wrote a database connector for Berkeley DB for Scheme. I think it still exists somewhere, but yeah, projects of the youth.
Okay, so what are you showing us today? And maybe you're going to give us an introduction to Quarkus, first of all.
Absolutely. So by coincidence, I've prepared some slides on Quarkus, which I would actually show you. Because as you mentioned, I think at some of the previous coffee breaks, you showed pieces of Quarkus. I think you showed some advanced topics, microservices, distributed transactions. But I think it's important to take a step back and have a look at Quarkus and especially Cube native Java, because Java was really invented in another time. Before we had containers, before we had Kubernetes and OpenShift. So it's really important to see where we came from and why Quarkus was invented, why it's really the vision for next level of Java. So I think if you can share my screen, yeah, that looks good. So let's get started with that. I just recently, or I think yesterday, I pulled the current TIOBE popularity index for programming languages. And it's always interesting because Java is always at least in the top 3. I mean, it jumps to the top, then sometimes it's on level 2 or 3, but it shows you it's been popular, one of the most popular languages through all this time. And as I mentioned, it's not just the language, the construct, it's the people, community, the knowledge, the tools, the CI/CD tools, everything out there. And while Java was actually envisioned to be something that runs on coffee machines, for example, and as applets in browsers, it's really more common now on the server side to run it as well. But when we look at what is actually being deployed on Kubernetes on OpenShift, and that's really where the value comes from when you have something like OpenShift, the workloads on top, it really becomes apparent that Java has been designed in another time, where you deployed your workloads on bare metal servers, on virtual machines. They would be developed as monolithic applications to be run for a very long time with high throughput. And now when we're talking about cloud native, containerizing application, containerizing workloads, especially microservices, as was mentioned in the previous coffee breaks, when you have different small services communicating with each other, and then even going further to serverless, when you have sort of stateless workloads that can scale up very fast, that can use resources efficiently, and especially these kind of event-driven architectures, maybe talking through a Kafka system where everything is an event in my system, something like an online shop order, any kind of logging information is an event in my system. This is really when we see other runtimes being used more often. I think you will encounter, when you're looking at OpenShift, a lot of these microservices being written in Node and probably also Go, which makes sense since Kubernetes itself is written in Go. And these languages are being perceived to be, more sort of lightweight, easily scalable, while a lot of people are saying, Java is a little bit clunky, needs a lot of memory in that, and it's not really being perceived as the sort of cloud native runtime that much. And why is that? Well, as I mentioned, it was created in another time when you had like an operating system, you had your Java virtual machine, you had a big application server, you had some frameworks which were specific for your applications, and then you had multiple applications running on your Java application server, being packaged as WAR files, as ER files, and these would run for a very long time. They would need a lot of memory. They were, you would actually put updates into them maybe, I don't know, every half a year or so. So it would be fine if they ran for a long time, even though they had like very long startup times, but it doesn't really match the model of Kubernetes very well.
If I can interrupt you for a second.
Sorry, absolutely. Go ahead.
Going back to, but you don't need to go back to the previous slides, but you mentioned other languages that were considered more suitable for containers. But it's not just about the language, is it? It's also about the number of ready-made libraries and frameworks that you can use on that language to deliver an application. So I guess Node.js stacks rather well for that. I probably wouldn't consider Go in that same category, correct?
Yeah, so that's exactly what I was going to ask Andrea. And just to add on top of that, before Daniel gives us like a complete answer, I think like the complexity of the code constructs needed to do some recurring patterns. I think with traditional Java, it took a lot of bootstrapping code to be able to have a functional, to do something like CRUD or basically with what we used to do with Java beans or whatever. And I think those languages offered very much simpler code constructs to be able to do these things. And that's probably why they got adopted also on top of the the performance and the lightweight side of things. Can you tell us in that regard how Quarkus has tried to change the game So you said also something about documentation, and I think that was really something that changed in the Quarkus way of thinking about user experience.
That's actually a very good point. I'm actually going to get to that, and it used to be like a secondary point. Is really like the developer experience. How easy is it to get started, to scaffold a new project? What kind of runtimes do you have? How's the documentation? I think Java really lacked that in the past, and I think some of the other runtimes were better at that. So definitely a valid point. But Quarkus really is trying to address that developer experience, the developer fun in itself. So next to the actual runtime performance, which I'm currently at, the actually developer experience to get started is very important and is a high priority on Quarkus. So I'll definitely pick up on that in one of the next slides. But to say for the moment, to just stay with runtime to finish that off, I was just saying what's really happening or has happened with also the other kind of Java frameworks out there, application servers, things like Spring Boot, they were being packaged into containers without really changing them inherently. And while you can actually do that, it doesn't really give you this kind of cloud native performance that you really want because you're still packaging the whole application server, the whole runtime into a container, into a hotspot, with a virtual machine into a container. And it doesn't really scale very well. It's not really that lightweight. And especially for this kind of serverless, elastic scaling workload, that's not really what we want. And sort of like what we say, the hidden truth about Java and containers, and I've heard that a lot from, for example, Red Hat partners I'm supporting and also customers, is because of the dynamic heap of the Java applications. You need to cater for this kind of additional memory which an application may need to consume when it starts up. So that means you need to give it some more memory, footprint, some more memory, sort of additional buffer, so it can actually start up, even though if it reduces later on. And that means you're not really using your node, your resources very efficiently, because you need to cater to this kind of additional buffers, while you can add more node or maybe more Go applications on your node. So it's really use of efficient resources here. So what really happened here is that a lot of experts, from community projects, from a lot of great Java projects out there, experts from Red Hat got together and really tried to envision what Java really could look like for the future. What's really the next level of Java, especially on cloud native. So a lot of people from projects got together and thought about, what does a Java developer nowadays need to develop that? And that's really how Quarkus was derived as a supersonic, subatomic, next generation Java being cloud native. And it's a community project, Quarkus.io. We'll have a look at it. And so what Quarkus really does is it takes the sort of optimization which traditionally have run when the application was running, the hotspot optimization. It takes this kind of optimization to the compile phase. That means it's doing very aggressive optimization. It's removing redundant code. It's doing a lot of optimizations in terms of what you really don't need during runtime. And with that, you get a very lightweight, actually executable that you can run. The Java, actually, which you're compiling is more lightweight than a similar something that you would have from another runtime. But you can also do a transcompilation to a native binary. So you can, at the end of the day, you can have a Linux binary that can start up in a matter of sub-milliseconds and has a very low memory footprint. And this really gives you the kind of optimized Java runtime that you really want inside of your cloud native environments. A startup, very
One
small.
quick question
Yes,
before you go ahead.
Yes.
You mentioned so the comparison is with the traditional cloud native stack. So what would could be considered traditional cloud native stack, like the ones you mentioned before, like Node.js or, I don't know, Spring Boot on Java?
Yes, this is comparing now to other Java frameworks. This would be,
Java,
for
okay.
example, something like Spring Boot on Java, or other application servers that you might just package inside. They're again not really optimized. They might be great frameworks, but they don't have this kind of optimization yet. I think in the future we will probably see this coming in more frameworks due to Graal VM. This is something that other frameworks may tap into in the future. But at the moment, I don't think there's anyone as advanced at Quarkus right now. So that really brings us to this kind of highly efficient usage of our resource. And this is really what we want, the elasticity, to really deploy a lot of workloads on it. And so you can have, when you do the Quarkus native compilation, hard word, you can put a lot of these workloads on your nodes and have a much more efficient usage of your resources. I think maybe one thing to mention here is if you pitch a sort of like classic, application server application against the Quarkus application on a VM or on a bare metal system, the single application server would actually perform better due to the runtime optimization. But the real power of these resources are being tapped into when you have multiple instances of Quarkus running and you're sort of distributing your workload and thereby reaching a lot of higher throughput. So
in your previous
yes.
slide, I just saw a glimpse of it, but then you skipped to this one. You mentioned that the two paradigms, the two style of coding, the imperative and the reactive one, and that Quarkus supports both. Are you going to talk about it a little bit later, or?
I think I'll quickly mention it. Yep, it's coming up. So
excellent, thank you.
But good point. We have some Quarkus experts in the round, so I'm hoping I'm telling you something new here. And again, if you have any questions, let me know. Okay, and that brings us actually to the second big benefit, next to this efficient usage of resources. This was, as just was questioned before by Jafar. And it's really about the developer joy. And for me personally, I think this is even, moving up to be the benefit number one. Because in my experience, I've worked a long time with different application servers, also with Spring Boot, which I think is a great framework. But I always used to struggle with, getting extensions to run, getting something like OpenAPI Swagger to run, finding the right documentation, what things to configure. And with Quarkus, it was really like a feeling, wow, this is it. This is how Java was supposed to be, before that, because things just work. You have some unified configuration. You know where to configure things. It's not sprawled all over your code and annotations and different kind of property files. It's really centralized. The documentation is very good. Things just work out of the box, but you can still adjust the things that you need. So it's a very nice experience, and especially the hot code swapping. I mean, that would have saved years of my life during my Java development time. I remember waiting for what felt like hours for a redeploy on these big application servers at some of the automotive companies I worked for. I don't know if you had that kind of experience as well when you were working.
Definitely with JE application servers, the ones I work with, especially when you start adding frameworks on that and you have dependencies and all that. And there was hot deploy, but in the end, to bring everything up, and in some cases you wanted to bring up the application server again for a number of reasons, it would take ages. Yes, the cycle was very long.
Yeah, and so if I could also comment on that, what I really liked when trying Quarkus. So I'm not a Java expert at all. I know my way around Node a lot more, and what I found useful. So first thing, like the live reload thing, which is, I mean, a very enjoyable experience when you are making your changes and can see things on the fly. I mean, it makes a huge difference when you are iterating a lot. Also, especially if you're not an expert developer and you have to fail a lot before it works, that's saving a lot of time. And what I liked also was the use case oriented documentation where basically you ask yourself a question. So how do I it's a little bit it was a little bit like that also I think in Spring Boot, but basically how do I externalize configuration, how do I connect to an external database, how do I distribute cache, for instance, etc. And basically you have very precise code samples or code starters that you can refer to. Whereas before, I think the documentation around Java was more, we know you are a technical expert, and here are the in-depth details that you need to know about, but it doesn't tell you how to like quickly get up and running and have something uh, easily created in terms of code constructs, etc. So for me, it was, I would say, as a Java noob, it's much easier to get started and have things working and find code samples. So that's definitely a big leap in the I would say the developer experience when you are getting started, especially.
Yeah, absolutely. I can only agree with that. I mean, especially the getting started experience, but I would say also when you're working with more advanced topics, there's a lot of documentation out there, and things just work together also in the versioning. I think I will show you soon when we're through the slides to see for yourself. So especially, this kind of developer experience, developer joy is just fun to work with. Okay, so here's Andrea's favorite, the reactive. I won't go too deep into that, but let's just say in the past, if you wanted to use, apart from the imperative development style, if you wanted to do something reactive, something non-blocking, which is very high performant when, for example, consuming from a Kafka topic, you would have to use a completely different runtime or like special libraries or something like that. In Quarkus, you can actually mix these. You can mix imperative and reactive programming style and it's actually quite easy to use. You don't have to be like an expert in Vertex, for example. You can just use it directly by with an injection with different kinds of reactive models. So have a look into that if you're working with event driven systems. And I think that brings me almost to the end. Just as a side note, Quarkus brings a lot of extensions with it. We'll see them right now when I'm going to do the demo. But just to inform you, there are a lot of Quarkus extensions out there. They have been quarkified, what we call it. That means you can use them to create the native binaries. You can actually use any kind of Java library that you want, but not all of them may be able to transcompile to native. That depends on the kind of optimization that's possible there. But apart from that, I mean, there are more than enough of all these standards kind of libraries and extensions out there that you can use.
I have another question, and this is
Yes.
actually a curiosity of mine, and I'm wondering if any of you guys know this. But when they quarkify that term, a framework, do they make sure that the I/O is non-blocking so that it works with both paradigm? Again, my pet peeve, I guess. The reactive versus imperative. Is that one of the things that they do?
So
It's a question. I'm not sure if.
Yeah, I'm not really an expert into. I haven't written any extensions of my own on that. I think the most important part is really that you don't have any kind of reflections, because reflections means that classes will be picked up during runtime, and this is not something that can happen in a Linux binary. I mean, you need to tell it what classes it will actually use during runtime. You need to inform that. Regarding blocking, non-blocking, I'm not really sure. I think they are specifically then reactive or not reactive, the extensions, as far as I know.
Okay.
Yeah. So, for example,
the end goal is to be able to get an executable. That means that you cannot have reflection in the end.
Yes, exactly. But I think there's, for example, there are reactive database extensions. They are specifically labeled reactive, as far as I know. So when they connect to the database, they're essentially non-blocking. Okay, so yeah, that actually brings me to the end of my slides. If anyone's interested, head on over to Quarkus.io, which we will do. It's the main site. There's a Zulip chat from the developers, from the community, which is very helpful, which I've heard. You can contribute, you can open issues. There's the code generator, which we'll use right now, the guides, blog articles. So, this is your hub where you can get all your Quarkus information. And with that, any question from your side on that? If not, then I think I'll show some code if everything works.
Show me the code, dude. So we don't have additional question from the chat. Actually, I want to say hi to Anna, which is in QCon, a conference, Java conference in London. So she's following from there. Maybe with a QCon audience. Thanks, Anna. And if you have any question, please bring it in the chat. We will bring to Daniel just to put pressure on him. And now, Daniel, let's go for our, as promised, the live demos.
Yes. Speaking of pressure, I hope the demo gods are aligned with me. So when you want to get started with a Quarkus application, there are several ways you can start your projects. You can head on over to code.quarkus.io. It's probably the easiest way, and this is what we'll do. But it's also possible to use a Maven archetype. If you're familiar with Maven, this is a way you can scaffold a project. But there are also extensions for IDEs such as IntelliJ, VS Code, etc., where you can generate your application. And quite recently, we also added a CLI, a Quarkus CLI. I'll also show you that. And you can just say new app, and it will also generate a new app for you. But I always like to show the code generator here because, it sort of looks familiar. It's more visual. It's easy to understand what's really happening. And I think it's also important to show that, this is a standard Maven or Gradle project. There's no real sort of magic happening in terms of that you cannot understand what's happening. It's all standards based. It's a standard Java project. It's using the Quarkus runtimes, doing the optimization, but in itself, you can, use it as any kind of Java project. So when you head on over here, there's some configuration parts which you can take a group, your artifact ID, what kind of build tool you want to use, the Java version. I will just keep that as it is. We want to have a small REST service, so I'm checking the REST JAX.is, which will also generate some starter code. And I think that's about it. So from here, I could have pushed it to GitHub if I wanted to. I can do authentication and would already have a repo in my GitHub, but I'm going to download it as a zip file. And I'm going to put it into this folder. Here's my terminal. I hope it's big enough. If I need to
If you can increase the font, is better because
Yes,
we have
sure.
this embedded window. I think it's good.
So can you still hear me?
Yes.
Yes. I think you were breaking up for some seconds. Now we can hear you. We can see you.
My audio dropped. Just a second.
No problem. By the way, I like this code Quarkus.io. It's really easy to scaffold a new project in this way. And I haven't noticed that there's the push to GitHub button, which is really cool. We lost Daniel, but
I think we did lose Daniel. Let's hope he managed to get.
He will come back. Oh, I was not. He was using OBS, it's a nice setting. We also use OBS with our virtual background. But anyway, in the while that Daniel come back, Andrea and Jafar, I think it's very cool what you say. This kind of new feature of having hot the code reload automatic, like in other programming languages. And another cool feature, what maybe we haven't mentioned too much, is really the memory usage. I think one of the best value of Quarkus framework is the optimization in memory. You can see the benchmark. You can compare. If you want to do really cloud native today, you want to do serverless. You have really to optimize resources. And I think they made a really good job. What do
I
you
also
think?
like this other optimization that obviously they do when they get to the executable code by removing analyzing the code and removing all the dead code and libraries that are never used within the application. That's quite powerful because it reduces the footprint of the actual executable.
Right. Hey there.
And
hey, hello.
Daniel's
Sorry about
back.
that.
No problem.
Somehow.
We've seen you are using OBS, which is cool. It's a very nice software for streaming. That's why you have the nice background, I imagine.
Yes, exactly. That's where the background comes from. But sometimes I guess it's a little bit too much in terms of performance. So let me see. Can bring back the sharing.
Are we ready?
Yes, I think we should be.
There you go.
There you go. Okay, so apologies about that, but as you know, it's live, and it can be rough on the edges, but we'll just pick it up from here. So as I mentioned before, I downloaded the zip file, which is here. So I'm going to unzip it now. Going to switch into it. Let me just pull that up. The code with Quarkus, and I'm going to open it. My favorite IDE, which is VS Codium at the moment. Let me just make that a little bigger as well. So essentially what we have here is, as mentioned, really a classic application. You have your source, main resources. You have your Java folder with a single generated class. And this is actually our REST service. This is not doing much except for answering on a JAXA S-path hello with a hello REST easy. And the resources is actually the single point of application properties where we define all the properties that we need. And that's about it for the moment. We have some test classes that we'll look at quite soon. But let's fire it for now. So just bring up my next steps. So let's open a terminal, and you can execute all the commands that you want to as Maven. It is a Maven application, but we're also offering a Quarkus CLI, which I'm trying to get used to a little bit. So to really run that, you can just type Quarkus .dev, and it should fire up the application. So I will, of course, download some of the Maven libraries, which is definitely shows you that it's a Maven project. And and with that, I think it already started. So let's head on over to a web browser, and it's running on localhost 8080. And this is what it looks like. This is your first Quarkus application. There's actually the endpoint, which we have published, is being showed up here. It's the hello endpoint. And when we click on that, we get a REST answer, hello, rest easy. And if you remember, this is what we actually have defined here. So let's change this to coffee hour. I'm going to save it now. And I'm going to head over here and reload it. And it switched to coffee hour. And, again, as someone who worked with Java for a long time, there was always the promise of hot code reloading, but it never really worked, or you had to buy some additional tools. But, this just works out of the box and is very nice, because in the background it's doing recompiles, swapping and everything. So if you're coming from other runtimes, you may be used to this, but as a Java developer, this is definitely great. I hope you're as excited as me.
Nice, nice. Oh, yeah, yes. If you can live fix it to coffee hour to coffee break, that would be also cool.
I'm going to do it just for you, Natalie.
Yeah, it's live, so let's do it.
Just too much coffee going on here. So I'm going to switch it for you. And there you go, the coffee break.
Yes.
Screenshot.
Nice. So, okay. So when switching back, you may have noticed in the console there's some kind of interesting output in the bottom. It's saying test paused and press R to resume. And this is something that was introduced in Quarkus 2, which I think is also a very great feature, because this means there's a permanent testing of our tests going on, which will tell us if our code, what we're working with, actually fits our test. And normally you should do test-driven approaches. So let's see what happens if I press R for resume. Any thoughts what might happen from you guys?
I have a question that comes a little bit before that. So when you generate the scaffolding using that, does it also generate the test harness?
Yes, it does. Actually, okay. I was actually going to get to that, but you, of course, found it before me. No problem. So let's see what happens when I press the R for resume testing. So it's starting tests now. And bam, there's a test failed. And why is that? Well, if you look into our test folder, there's a greeting resource test. And if you look into here, we see that this is doing an assertion. It's actually calling our hello endpoint. And of course, it's expecting hello rest easy. So as Andrea mentioned, when you generate the code, it will actually generate the first test scaffolding as well. And since we changed it now to coffee break, this will, of course, fail. And as a good test-driven approach, you would normally fix your tests first, define your test, what it's supposed to do, and then go back to your code. So let's change that to coffee break.
Good that you
Save
remember
that.
exactly the string you put in.
Yes, since Natalie called me out, I need to. And so I just saved it. I didn't do anything else, and it automatically ran the test. The test passed. We're all green, so we're good to go.
Nice. So Daniel, do you think this enables test-driven development? Finally?
I think it absolutely does, because this is something that you can permanently do during your coding. And this testing is so advanced that it picks up where you changed your code, and it only runs the test that touched the changed code. So it doesn't run all the tests if you have like a big test suite, but it only runs the code that touches your changed methods. And I think, that's very advanced. It runs in the background permanently. It's not just like a Jenkins CI that tells you hours later something is wrong. It's telling you immediately.
And of course, this is the dev mode, right? When you ship it to production, you don't enable this profile. It's only local. Yeah, right.
Yes, that's a good point. It's possible to define different kind of stages, environments, and in production, a lot of these features are, just disabled. You wouldn't want them to be active in production, of course. Yeah, good point. Okay, so so far we have an application that says "Hello Coffee Break," which is quite nice. But how about, we want to see what kind of APIs, what kind of REST APIs we've published to test, or maybe to give to another developer of another microservice to talk to. And this is where Swagger or OpenAPI comes in. So let's see how we can add another extension. For this, I'm going to create a new terminal here. And with the command Quarkus text list, I can actually show at first the extensions which are currently installed, which is not that much. It's just the one which I selected. So yeah, it's just the REST easy one. If I add the -i, it shows me all the extensions that I can install. So this will probably create a pretty big list here. Yeah, it's for the size, you see there's a lot of things going on. And actually prefer to switch over to the code generator, because this is where you get the full list as well, and it's more easy to see. So when I start looking for Swagger here, it shows me immediately the small Rye OpenAPI extension. And if I click on the right side here, it will give me immediately the CLI command how to add this extension. So I can quite easily add it by copying, and I'm heading over now to my VS Code, to my second terminal, and I'm pasting it in like this. So Quarkus extension add, and this is the name of the OpenAPI extension. Let that run. And I'm adding some more superpowers to my application now. And if I switch over to my still running application, by the way, you will see that it should actually recompile. I don't know if I already did it. Yeah, I already see it, small Rye OpenAPI. So let's have a look back. So if I go now to, I think it was called Q Swagger UI, I have it immediately.
Nice.
So I mean, this was without redeploy or anything, just adding the extension, doing the live running system, and I have a nice Swagger UI with that. And I have my Hello endpoint. Any expectation what kind of answer it might give me?
what we deployed before, no?
The same.
Yes.
Same as before.
Just
break.
checking if you're still with me. Yes. There's the hello coffee break. Perfect.
Fantastic.
So that's the way to add extensions, and I mean there's so many here. I don't know if you have used any, or if you have any kind of popular extensions. There's like gRPC, Hibernate, REST client, whatever you want is here, has been Quarkified. And again, you can still, of course, use any other kinds of that you want as well.
This is very cool. So it looks very easy to do a simple RESTful API, like API endpoint, and probably attaching a databases. And I'm looking at this data. There are lots of connector.
The data connector look also quite extensive. Yeah.
Exactly. There's like almost more than enough. And again, you can add whatever you want. But if you use an extension outside of these ones, it may not be possible to do the transcompile. But again, even if you do the Java compile, you will still get a very lean, lightweight Java application. So it might not be necessary to do the actual Linux native compile. So, but since we're here in the OpenShift coffee break, let's have a look at how we get our workload on OpenShift, because this is what we are really looking for. So I'm looking for the OpenShift extension. This is this one. Just copy the command. You already know how it works. So I'm going to paste this here.
So Daniel, this will just add to the, if you're using Maven into the POM XML, if you're using Gradle in the build Gradle, it's adding the extension dynamically, right?
Yes. Good point. So this is what it's actually doing. It's adding the right extension to your POM XML. You could have done it by yourself if you wanted to, but this is a lot nicer because you get the right version and everything, and you don't have to care about copy and pasting it. Yeah, good point. Cool. So let's have a look at our resources application properties file, which I mentioned. This is our kind of central resource definition. And now we need to add a couple of properties to be able to publish that to OpenShift. And let me find these properties now. So I'm going to paste these in and explain to you what they are. I need a couple more here.
So I guess each extension will have a set of properties that you set up in the application properties.
Yes, exactly. And it's also nice if you have the Quarkus extension installed. You get code completion, you get some information what these properties are. But essentially, yes, every extension has a set of properties. You can either set them when you start the application dynamically, or you can add them to the properties here.
So Daniel, you have also an extension in Visual Studio Code for Quarkus?
Yes.
Oh,
exactly.
Okay, cool.
So if you have a look at extensions, and where is it? There you go. You can just look for Quarkus. It gives you the generator for the application. It gives you the sort of the information on your property files, code completion, things like that. Anything that you may need. It's a really nice extension. There's one for IntelliJ as well, for Eclipse, if someone is still using it. So go ahead and use that. You can use it without, of course, but it makes things a lot easier. So a couple of things here. So I added some properties. These ones I have to add because my OpenShift doesn't have a valid TLS certificate. So I just need to tell it that to trust it. This is not something you want to do in production, but of course for a test here, it's fine. It just means, deploy to my OpenShift while trusting the certificates. This is telling it, okay, when you're deploying this application, also expose an OpenShift route, make it accessible for the outside. And these parts are really kind of magic, which I'm going to show you, because we can actually do a live code swapping to a running OpenShift Quarkus application. So I hope that works. These are things you need to set up a password, a reload URL. You need to give it a environment variable here. And with that, you can actually do code swapping while it's running on the system. And this can sometimes be useful because the application may need to use third-party things such as maybe Kafka or applications which are only in the OpenShift system.
So Daniel, this is
yes.
a kind of a remote dev mode?
Yes, it's a remote dev mode, correct.
Okay, cool.
Yeah, that's really nice. It seems like the audio stuff where you can basically replace or rsync changes to a live running code container.
Yes.
Except that it's directly here from the app, and it's not necessarily using audio to do that.
Correct. Absolutely. I mean, that's a good point. We have a lot of developer tools out there. ODO is an option that does something very similar with several runtimes. It pushes your changes into a running container because sometimes when a developer is sort of in the loop during developing and wants to push a small piece of code in, it doesn't want to create a whole new OCI image to push it up, because in that case, you can either do the Quarkus live reloading, pushing small changes in, or Odo, which you can do for several runtimes. Yeah, good point. There's some similarities here, so it's a matter of choice and taste, what you want to use actually. So let's have a quick look over in OpenShift. Let me just log in to my OpenShift. And I've created a namespace here called Quarkus. It's currently empty. Let me see if I'm still logged in. OC project. Yeah, I'm still on the Quarkus project. So I've logged in before, of course. So now I think I can actually already push it. Let me see. Do I need to do anything else? No, I think I can actually just do the Quarkus build and should do everything.
And this OpenShift, Daniel, is a generic which OpenShift version are you running?
I'm, of course, running the latest and greatest. This is something that I'm running on my Hetzner server. So we are now on, let me just see, administration, cluster settings, 4.10.6. Actually, I updated yesterday, which is probably not something you should do before a demo, but I took the risk. But this will work with any 4 OpenShift version, because inherently it's using a lot of OC commands to do the deployment and everything. So to OpenShift itself, it looks like a normal workload that's just coming in. So this has actually finished. Let me see.
Installing.
Yeah, it's doing the installing. Let me just see if there's anything I may have missed. Quarkus profile. Okay. Let me.
I remember there was Andrea Jafar. I remember there was Fabricate library used before, to do deployment in OpenShift and Kubernetes. It's a Kubernetes client that has an agnostic approach on doing this kind of deployment. But here we have an implementation that it's inside a Quarkus Quarkus engine. So I
Yeah,
guess
I was asking myself if under the covers it uses the fabricate library or not, but
yeah, I think it just missed two properties. Let's see if it works now. Didn't tell it to really push it. So another thing that
test.
Yeah. Okay, it's fine.
Target OpenShift. It looks like it's connected.
That looks good. Yeah.
Yeah. So it's a profile, no? It's also a profile injected dynamically.
Correct. It's also profile injected dynamically. And so we are currently creating an application where we're pushing in the jar, but it's also possible to do the native compile and then push it. For the native compile, you would need to have either GraalVM or a Mandrel. Mandrel is our sort of open source project to create these kind of native transcompiled binaries. And you don't even need to have it installed on your system. You can use Podman, for example, to have that compiled inside of a container. So if you have Podman running, you don't need to have GraalVM, or you don't need to have the Mandrel installed to create your native image, which is also quite nice. So let's see if something's happened here. Yes, we see the logo, and it's coming up.
Nice.
Open URL, and we should have the hello coffee break here. So we have.
Oh, here we go.
Coffee break on the system.
Natalia, just so this is great. Just thinking of something. We need to add a clap sound.
Oh yeah, the backstage. Yeah.
Media whenever we have successful things like this.
yeah, definitely. We have to add it. So Daniel, you deserved our virtual. Let's do it. Manual. For the next time, we will have sound, but that's really cool because we've seen you developed something, you changed your test, and then you deployed something to, let's say, production. No, It was easy.
And so, can we see how the live reload works?
Yes, I'm just doing it now. So I'm starting the application again with Quarkus Remote Dev.
Okay.
And I hope it should create a connection to the running system. So telling me it's connected. So let's see, any preferences? What to put in here?
Yeah, just add space between coffee and break.
Okay.
Absolutely make sure that you also change the test.
Oh yeah, and add an exclamation mark if you know that
also,
you are there.
Okay. It's requests over requests.
Yeah, we have demanding.
Okay. Our quality assurance team, it's very tough.
Italians, they don't mess with coffee.
No, not at all.
Obviously. There you go. That's running. Nice. That's running on OpenShift. So I've just switched the code there.
So what's with the password?
Please, sorry.
What's with the password for the live reload?
Yeah, it's super secret. You can set it anywhere, and it makes sure that only you can do the live reloading.
Oh, okay. So you have to invoke that URL and put the password, and then you get. Okay, nice.
Exactly. It's being part of the deployed application as well, and when you have the same password, you can connect to it.
Okay. Nice.
A couple things. I think we'll have to invite Daniel for another session because we still want to see MicroShift, and there are a number of topics that I'd like to see a little bit more in depth. Like, for example, reactive, event-driven. I know that we touched on those in some other sessions, but always functional to a problem. But I'd like to get a little bit deeper. But definitely, MicroShift is something that we would like to see. So we'll try and invite you again when it's possible, when you have time, of course. And as far as today is concerned, I think the time is up, and that's all we have time for. I would be asking the audience if they have any question for Daniel before we close.
I feel a little bad now for having teased people with the MicroShift and not showing it, but I suppose we have a hard deadline. Is that correct?
Do we?
No, Daniel. If you show us MicroShift now, we can make an exemption for you and
so
extend
nice.
5 minutes.
Yeah.
Okay.
And we offer coffee afterwards.
Yes,
that's perfect. So MicroShift is so small it will fit in 5 minutes. No worries here. So I'm just quickly going through. If you want to have a look at MicroShift yourself, head on over to MicroShift.io. It's a technology preview, or sort of technology investigation project, which we are currently looking into. It's an extremely lightweight version of MicroShift, really stripped down. You don't have the developer console, you don't have any kind of operators, but it can run on a Raspberry Pi. It has an extremely low footprint. There's some explanation on how to get started. Here's, for example, you need to install Cryo. You can run it locally as RPMs, but you can also run it with Podman, which is what I am doing. And essentially all you need to do is install Podman. And then this is really the way you can install it as a local service now. And I'm going to start it because I've installed it locally. Start and MicroShift and sudo, yes. So you will see this is fairly quick, and we have a lot of edge opportunities. But this is really something that's super lightweight and matches Quarkus very well. So I need to do a quick copying of my cube config here, because I was this is actually the way how you can connect to your local system. So let me just paste that now. Okay, and I need to change the owner as well. Okay, let's see. Okay, so this is already, I'm OC connected to my MicroShift. I'm getting all the pods here, and you see, there's not a lot of things going on. This is all the pods that are actually running. The thing is, if you want to get an application started, something that receives traffic from outside, you need to install sort of like a proxy or a load balancer. There's an example here when you head on over to user documentation and how-tos and deploy a basic application. It shows you how you can create a namespace with for the Metal LB, how you can install the Metal LB, and then it will create for every service that you deploy. Your Quarkus application will have a service, will create an external IP for that. So I've already shown this demo before. I'm going to quickly delete the Quarkus. Project. Yes. Project, yes. Trying to stay. Okay, so delete it now. So what do I need to get running? Let me head on over quickly to my sheet. So of course you need to have a pre-built image beforehand. You need to build it outside. You could build it with your Quarkus. I've pushed an image to the key.io registry, so it's available there.
the build service is not shipped in MicroShift. Is that what you say?
Do you mean the service registry?
No, the build, the
build service. Yes, correct. Yes, all the developer tools, everything that's not being shipped with it. It's of course the price you pay, when you get something so small. The idea is to have this on edge devices, IoT devices. You're building in a central hub on a central OpenShift, and you're pushing it out.
Yeah, makes sense.
So I'm going to go a little bit quicker now. So I'm creating a new project, namespace Quarkus, which I just had. Then I'm going to create a new deployment. Let's go quickly through it. So it's a new deployment called Quarkus in the namespace Quarkus. And as an image, I'm using from my Quay registry account, Hello MicroShift. This is essentially just the same as we've created before. Hello MicroShift. I'm giving it the tag. And this is also a native image, so it matches very well. It's very lightweight, and I'm firing that off. And as a last part, we need a service. We need to tell it how the traffic goes into our pod. So I'm taking that. So as a service, we're calling also the service Quarkus, the namespace Quarkus. We need this annotation. So MetalLB will take an IP from its pool.
So just one question here. I think with OpenShift, you can traditionally do like an OC expose deploy, and it will create the service.
Yes.
Does it infer here the annotation with the metal load balancer, or you have to explicitly create the service like this?
As far as I know, you have to create the service like this. It will do the inferring is by the MetalLB annotation. This is what is telling the MetalLB to create the IP and the connection, everything, but you still need to create a service, as far as I know.
Okay.
So let's fire that off, and let's have a quick look. OC get pods. So we are in the default namespace. And do that again. Okay, so there's a Quarkus pod already running. Let's see, how about the services? Okay, so this is actually the service, and the external IP will be the one that the MetalLB has will be used to route into the service. So if I copy this now and paste it into a local browser, see, this is a Quarkus application now running on my local MicroShift.
Nice.
Very nice. And is the API also exposed externally with the MetalLB, like the OpenShift API?
I think I would have to pass on that. To be honest, I'm not really an expert on MicroShift. I've just did like the really short test with the deployment.
Maybe if you create a service to the Cube API, probably, or to the OpenShift API server. If it's not there, it should be exposed, I guess. But anyway, we can figure out these things later on. But it's really nice.
Yeah, I think it's a good teaser to get started. But you're right. I mean, there's probably lots more things to discover about MicroShift here. But it's very promising. I just put like a super lightweight Quarkus application on my lightweight MicroShift, and this can run on probably on your smartwatch, I guess.
Yeah, very cool.
Congrats, super cool. We have a kind of a series of live demos. Congrats, Daniel. That was fantastic.
Thank you.
2 demos for the price of 1.
Yeah.
Natalia, I think it's really it's nearly we're 10 minutes past the hour. I wanted to ask you what's cooking for next week.
So next week we should have a session about a demo about Rhoda. Now that Rhoda is available on consoleredhat.com, Rhoda is our services for managing databases inside OpenShift, databases as a service from third party. So we're prepping a demo around that, and this for next Wednesday. For today, Jafar, I think there's the level up.
No, it's next week.
Next week, okay. So I think it's next. Ask an admin, right? Ask an admin. Yeah. Ask an admin here on OpenShift TV. And other than that, folks, I would really thank Daniel for this awesome demos. Very, very cool talks. You find Daniel on Twitter, and you see the handle on his image. So you can follow him on Twitter. Thank you, everyone, for joining us today. Andrea, Jafar, we have lots of cool stuff in April coming up. Do you have any final words for Daniel?
Thank you.
Well, hopefully you'll come back again and show
Right.
us something again from your research. And thank you again for joining us today.
Thank you, everyone.
Thank you for having me. Goodbye.
Bye-bye.
Bye-bye.